Yes, infinite series. Taylor and Maclaurin series are infinite series that we are going to explore now. Now, the form of convergent power series is like fx series is summation of a and x minus c to the power n for all x in an open interval I containing c. Let us say a function f is represented like this. Then series is the summation of all this. Note here, we have solved before exercises about how we can find first, second, and nth terms of series. Here we can say that if n equals to 1, we have from this A1 here, we have f1c, f to the power 1, f to the power 1, f to the power 1, c, a constant multiplied by a constant, or in terms of constant. F is a function. If we say that f is a function of c, it's like c squared plus 2c, something like that. So we can express f as a function of c here, and over n factorial. N factorial, n is 1, 1 factorial is 1, 1 factorial is 1 here. So we have f to the power 1c, and this is of course f to the power c. We don't need to write this one, you know. And the function f in terms of c. So this is the first term of this series. When we insert n equals to 1, we find that if this series, the first term is function f in terms of c. Now the second term of this series. This is not a sequence. Let me recall what was a sequence. A sequence was separated by commas. Okay? They were separated by commas. Now here we are adding them. We have a plus sign in between. These are series. They are different than sequences, but we also have first term, second term, third term in series and sequences. Now this is series. We are adding them. And let us see what is the second term. Second term, A2 equals to here. A2 equals to, we are going to insert 2 here. So it is f to the power 2. The function f to the power 2. Yes. And here what we are going to have over n. By the way, this is the summation of a n x minus c to the power n. So the first term here is we say it's fc. The second term we can have it as, if we have just one moment, if we have it as 2 here, then we have 2 factor, we have it 2 factorial, okay? And now here, this is the function here, this a nth term. Look here, now what we are calculating, we are not calculating this f function. This f function, let me open that also. let me open this f function here. This f function, this fx, let us look to this fx. Fx equals to, let us open this a little bit. This a1, you can see that this function is a1, x minus c to the power n. To the power n is 1. To the power n. This to the power n. Okay, plus this f function. It is a summation of this a and x minus c to the power n. It is a summation. So we are going to have now a2 for this. So I have a2. So this is 2 and this is 2. Then I have a3. Okay, because it is a summation. Then I have here a3. Then I have here a4. Okay, so until where? If I don't have borders, until infinity. But if I have any borders, I write what are the borders. I don't see any borders here, so this means that it goes to infinity. Okay, if you don't write borders, you can say that it is an infinite sum. It is an infinite summation. So here again, okay, this is 4 and that's 4. This, by the way, this is first term of this series here. Okay, this is first term of this series. Now I am going to rearrange this so you can see both of them in the same page. Just a moment. Oops. Okay. Yes, now we can see both of them at the same page. Now, this is the first term of this series, this power series. Okay, this is the first term of this power series. This is the second term. This is the third term, fourth term. Okay, and we don't have any borders. Therefore, it continues until infinity. Plus, it continues. This means it continues. Okay. Yes. Now, what I find here was fc, function f in terms of c. Okay, this is a function f in terms of c. It's not important what is the content of this function. This may be, for example, okay, this may be 2c plus 1, something like that, okay? Or it may be 2c to the power plus something like that. The content, the exact value is not important for us. These are just example. Any function of c, okay? This is any function of c. I am deleting it. This is just it's not important what it is. Okay, so this is general expression for a function of c. How do we come here? We are just interpreting this power series here, okay? We are trying to understand what it means. Okay, so when n is equal to 1, here we see that we have fc. Okay, but here what we have, you can see that we can write this one and we can have 0. And n is equal to 0, but we have here 0 minus c. Okay, so this is when n is equal to 2. So this we can have here fx. We can have here for this second term. If you want to write the second term of fx, second term. Okay, if you want to write second term, then we have fx equals to, this is this formula here. This is the second term, A2. This is the second term, this one. Then multiply by this one. Multiply by x minus 2. X minus c. Yes, x minus c to the power 2. To the power 2. By the way, this expression is important here. If we just a moment. Okay, now here, if we mention that these are derivatives, okay, then we should always say that these are derivatives. Now this is here. These are if these are derivatives, then we can also write it like this small dash, okay. If these are derivatives, we can write it as small dash, okay. Then here we would have yes, second derivative here, 2 dash, okay. Yes, so this will not be equal to that, okay. So yes, so sometimes it may be confusing which one is which, okay. The solution is same, but if we talk about derivatives, I will write you that it is a derivative here. Now let us say that if this is a derivative like this equation here, okay, if these are derivatives, then they are same. If this in this formula, okay, you see that this n is not a power, okay. I solved it like a power equation. Now if it is not a power and if it is mentioning derivative, then everything is same again. Just we have to make sure that when n is equal to 1, this is f1 c1 factorial, and it is 1. Now if it is second derivative, we write f2 like the power. I solved it in an easier way. Now with the powers or the derivatives, it is equal. Just if it is a power, then this equals to f c. But if it is a derivative, you know that this doesn't equal to f c. This doesn't equal to this f c. If it is a power, then it equals to f c. So we have to be careful about whether it's mentioning a power or a derivative. Yes, I solved it as a derivative equation now, and you can see that this second term is like this. And now with a1, when it is 1, we can have here the first term. Let me write. First term is here, okay. In the first term I have fx. In the first term I have fx equals to here. What I have to write, you can see that in this formula, in the first term, to find the first term of this formula, I have to write a1. Okay, what is a1? A1 is this one. So let me write first of all, like I see it in the series part. This is a1. Okay, this is a1 here, and this is x minus c to the power n. Okay, so x minus c to the power n to the power 1. So that's to the power 1. Okay, so now I'm going to substitute this a1. Okay, I'm going to substitute this a1 to find the first term here. So the first term becomes first derivative of c. I can copy it from here. First derivative of c and multiply by x minus c. Okay, so this is when n equals to 0. This is where n equals to 1, n equals to 2, and this is n term, and it continues. It continues because there is nothing writing here. When there is nothing writing there, it means it goes to infinity. Now, this type of series, okay, if it is like this series writing in this form, series writing in this form, infinity, just infinite summation of this an, infinite summation of this an, x minus n, an, yes, an, and x minus c to the power n, x minus c to the power n, x minus c to the power n. This infinite summation of a and x minus c to the power n, where we use derivatives, here, first derivative, second derivative, third derivative of the function f, and we divide it with n factorial. This is called power series. Okay, so if we have derivatives where f, I have to write it again here, where an equals to f to the power, this here, when we express it not as powers but as derivatives here, okay, when we express it as derivatives, okay, it has a similar notation, so be careful what it expresses, okay. So it should be said in the equations where this is a derivative, and sometimes even this small brackets, okay, be careful that even when it is expressed in this small brackets, then it is used to discriminate it with the powers, okay. So sometimes when I don't write this, when it is written like this, it means power, okay, and when it is written in brackets, in most of the books, in fact, they mention it as a derivative, okay. There is a very little difference between them. When we have these brackets, it is a derivative, okay, and when we don't have brackets, it is a power question. Okay, so when it is a derivative question, and here this is factorial, here when it is a factorial, this question, this series is called power series here. Power series and Taylor series. Taylor series, yes. Okay. And yes, let us pass to the second other slide. Yes, now this is the open form of it when it is equal to 0. This is the open form of this series. Now look here, it used this 0 and infinity borders also, okay, and when it is like this, now wait, okay, here, okay, yes, we are in the correct place. Now this is fx, it is a function x in terms of x, and this is a triangular expression, and we are going to convert it, we are going to write it in the form of Maclaurin series. This means that we are going to calculate it, okay? We are going to calculate it, we are going to put 0 first of all here. So we are going to calculate this one. How we can calculate it? This is fx, this is the first term, okay? Fx sinus x. Now here we are going to put 0 at first. We are going to insert, this is the 0th term, n equals to 0. We are going to insert 0 first of all. Okay, this is n equals to 0, right? And n equals to 0. Yes, this is n equals to 0, and this one is n equals to 1, and the other one is n equals to 2. So we are going to, just a moment, we are going to, okay, now here, be careful. Now this is n equals to 0, this is n equals to 1, this is n is different and 1 is different. This is n equals to 1, and here this one is n equals to 2, this one is n equals to 2, this one is n equals to 2, and here this is n equals to 3. Okay, so what about the zeros here? They are here. You can see that what was our Taylor series? It had another constant c. So here c is 0. So what you are seeing here, all the zeros are in fact the value c in the Taylor's theorem. Here, okay, here c is 0. Okay, n is the first term, number of terms. This is the first term, this is the second term. Sorry, this is the 0 term, number 0 term. This is, sorry, this is first term, this is second term, third and fourth. Okay, but we are seeing zeros. What are these zeros? These are this c here. Okay, these are the c here, value c. So let me write it from here. So c equals to 0. C equals to 0 for all the above. Therefore, we have f0, first derivative of f0, second derivative of f0. Therefore, we have them. Let me write. Okay. So for all of these, c equals to 0. Therefore, we have f0 and here we write everything in terms of 0. Yes, so here how we are going to continue. Now we know value of f. Here it is given us that it is sinus x. Okay, so value of function is a different thing, term is a different thing. This is a 0 term, first, second, third term, and we have a constant c. It is 0 here. Okay, so here the first term, this is the 0 term, f0 here. So we have to, sinus 0 is 0, and first derivative of cosinus x, sinus x, the first derivative of sinus x is cosinus x, and when we insert 0 here, we have cos 0 is 1. Okay, and here we have second derivative, as you can see, minus sinus x, and we have 0, 1, 0, minus 1. Okay, so here, and it continues like that. The fourth derivative is 0, the fifth derivative is 1, and so it repeats like that. So let us look. We are again our questions are taking more and more space. You know that this is the question. This is the first, second, third page, 3 pages. So they are getting a little bit longer and longer. We are in the same question now. Now what we are doing? This is Taylor series. Okay, Taylor series, and we have constant c as 0. Okay. Wait, no. Yes, okay. So here, okay, this one here, we write it as, you can write it like this. So, yes, this is another equation. I didn't finish it here, so let me finish it in MapTime. I'm going to finish the equation here. So I'm going to open a new page. New, okay. And make this smaller. Okay. So what was our function? Let me copy it from here. This was, yes, this was our function here. This, I'm going to use that